Greeting and a warm welcome. Greeting and a warm welcome to the future and fellow researchers to the first volume of the new and exciting Igniting Research Passions series hosted by the IEEE Women in Engineering Student Branch Affinity Group of the University of Jaffna. The series is tailored not only for the newbies who are excited to learn about researching and all the factors of it that come into play, but also for the experienced professionals who seek to learn a more detailed and thorough explanation about certain aspects of researching. On this wonderful evening, our esteemed speaker, Mr. Indrajith Ekanayake, will delve into the topic of opportunities and challenges in big data. Big data analysis has always been tied with research from the beginning, so it's more important to have a clear understanding of what the term big data entails, from the hurdles to the innovation it could provide to our fellow researchers. And Mr. Ekanayake is the perfect industry expert to deliver the topic today. Mr. Indrajith Ekanayake is an independent researcher who is currently working at codification as a technical trainer. He has also been a visiting lecturer at the University of Kelaniya and the Informatic Institute of Technology, his point of interest being big data itself. Most notably, he has also the recipient of the esteemed Most Valuable Professional Award, commonly known as the MVP Award from Microsoft itself. So a warm welcome to Mr. Indrajith Ekanayake, and we hand the mic over to you, sir.
Thank you. I hope I'm audible.
Yes, sir, you are.
Yes, sir.
All right. Thank you. So thanks for the nice introduction. Today, my plan is to discuss mainly possibilities of big data research. I framed the topic as opportunities and challenges in big data research, but these opportunities and challenges are quite relative terms. Sometimes opportunities lead to new challenges lead to opportunities. So it's sort of like a weird term, but I mainly want to discuss about the future possibilities and how the big data research came so far today, starting from 2000, I think, 4. So as the compere told us a moment ago, everything started from a research from Google. I hope she is aware about it, and based on that knowledge she mentioned, but that's true actually. Big data essentially started from research from Google. So let me share my screen. I think it would be more easier. Okay. I hope my screen is visible to you, the presenter view.
It's actually loading, sir, but yet not visible.
Is it?
Yeah, now it's fine.
Okay.
It's visible.
It's getting. Okay. All right. So is it still visible or it got paused? No, right? You can see the screen.
Yeah, it's visible.
Okay, thanks. So the topic is, as I mentioned, opportunities and challenges in big data research. So I'm coming from a background where I have studied big data academically. I have done a couple of research in big data, and I mostly teach big data as a subject in University of Kelaniya and some other universities. But as an industry practitioner, in my full-time role, I mainly work in cloud. So I will come into at the conclusion, at the end of the today's session, I will come and try to explain you how these two things are related, why the cloud is the future of the big data, and how these things are getting emerged over the time. And also feel free to ask any questions if you got any. Feel free to interrupt me, and yeah, so that's pretty much about myself and the session. I think we can dive right in. So initially, I'm assuming most of the audience are final year or third year or fourth year students. who are willing to do some research, are excited or willing, who are excited about research in general. And I hope the final year students probably planning for their research or already started their research projects as well, right? So I hope this would be quite helpful for you to decide your research topic, how to form your research in future. It will be a 1 hour session, but I will give an overview insight for you. So if we start first, I would like to start with the weeds. So when I speak about big data, I sometimes would like to ask some questions as well. So when I speak big data, what initially comes to your mind? So whenever I teach this session, this is the first question I ask from my students. So when I speak about big data, they can't say it's exactly how much big it is. So usually the big data, how I interpret and how the scientists usually interpret is a data which cannot fit into one single computer or one single server. So that's the standard definition of big data. Under that, I would like to discuss a little bit about challenges. Challenge in the sense, when we are speaking of big data in any sessions, maybe you also have some sessions of big data in your university. You might have heard of something called 5 V's: volume, variety, velocity, and what is the other thing? I just forgot it. There are 5 V's. So there are challenges attached to all these 5 V's. So in a way, 5 V's are sort of like a good way to understand big data and getting into the domain. And also at the same time, uh, uh, these 5 V's are helpful for us to identify the opportunities and challenges in big data. So I will start with that. So we are initially starting with the volume. So when volume in the sense, like as you can see in this graph, so this graph is taken from the website IDC. So you can see the data in zettabytes. So zettabytes is basically 10 to power 21, if I recall it correctly. So in 2024, currently in the world, the data volume exceeds 147 zettabytes, 10 to power 21. It's a very big amount, which we can't comprehend our head around. Gigabytes, then gigabytes, terabytes, petabytes, and then it goes along. And then when it comes to 10 to power 21, we call it zettabyte. So too much data getting generated. So that's the one problem itself. So when you have too much of data, we have the volume problem. So over the time, researchers, industry professionals, practitioners coming up solutions for those. So can someone tell me what is the solution for the large volume when it comes to the storing the data? What is the solution? I just wanted to check whether you have some background about big data. So when it comes to the volume, what is the storage mechanism for big data? Can we use databases or is there anything else? You can use chat box or even unmute and tell me. So when it comes to the storing, we don't use databases. When the volume increases exponentially, we actually can't use database and relational modeling. Yeah, there's a few answers I received. Cloud is one answer. Yes, in a way, cloud is okay, but it's quite generic term. So a more specific term which I'm expecting is data warehouses. So when the volume increases, we can't use databases to store the data. We need to go for compression mechanism is also in a way correct, but more specifically, we need data warehouses, data lakes, and data lake houses to store big data. So that's the volume problem. It's a challenge. when this data amount is increasing, ever increasing in exponentially, in future we might not be able to fit the data into data warehouses. In future we might need something else. So initially the researchers started to use databases. It was very slow. It's very hard to query the data when we store big data in databases like SQL, like MySQL like databases. So they moved into warehouses. Data warehouses have a different structure. We call it, most of the time we use star schema. Instead of like ER diagram and ER modeling, we use star schema. We call it dimensional modeling. I'm not gonna go in deep, just trying to give you an overview of each challenges and the opportunities. But if you have any questions, feel free to ask. Then I'm happy to dig deep and tell you about further. But that's the one problem, volume problem. Moving to the second one. Okay, why it's not moving? Okay, now it's moving. So variety problem. The data variety was also ever increasing. So mostly in your undergraduate studies, even myself, when I was doing my undergrads, I'm mostly dealing with SQL databases, SQL, right? So in SQL databases, there are some limitations. Can we store images? Can we store? I mean, images is doable. I think we can use the blob format, right? Blob format, and then we can store the images. But when it comes to the videos, emails, and different type of files, MP3 files, PDF files, it's quite hard. So when the variety also getting increased, it becomes a problem. The problems lead to more challenges and opportunities that you need to understand. So these problems researchers are continuously addressing with new tools, with new methodologies. So I will come into that at the end, how the people are addressing these stuff. But variety itself is a problem. The data variety getting increased. Just imagine, like in today's world, unlike in past, we don't have like relational data. We use SQL databases for relational data, right? So we have tables. In between the tables, we have relationships. But the world is moving more into non-relational data like NoSQL. We need to store images, videos, text files, GIFs, PowerPoints, MP3 files, and like so many. So variety getting increased, which leads to another problem. Another challenge is the veracity. So veracity in the sense, there are so many of sources, data sources. Data sources getting increased very rapidly. If you look back 10 to 15 years, I hope you are born at the time. So if you are born at the time, in the 10 to 15 years, the Facebook was not there, LinkedIn was not there. And the other stuff also was not there, most of the social media and the internet we use today. So, but in today, after 10 to 15 years time, the sources are getting increased rapidly. I read somewhere in, I can't recall the exact figures. If someone know, you can mention in the chat. In every minute, 300 hours of worth videos getting uploaded to YouTube. Just imagine how much of data it is in every minute, if I recall it correctly. 300 hours of data getting uploaded to YouTube. So that's a problem itself. That leads to more challenges, and challenges lead to more opportunities. So we exploit the opportunities as researchers, and we can bring up new tools, new architectures to gap the research, bridge the gaps. So veracity is a problem itself. Moving on further, another way is a velocity. So, okay, did I mistaken something? We discussed about veracity, and then velocity. Veracity is more of reliability, if I recall correctly. Yeah, the reliability also getting increased. The veracity, velocity. Yeah, yeah, reliability also getting quite important. It's also a challenge. It's also a problem that we feel, because you know, like if you look at veracity is more of reliability. You can't call it really call it sources. So veracity, sorry, pardon me for that. So veracity is more of really reliability. Like if you get some data from the LinkedIn and if you get some data from Facebook, which data are more reliable? If you get some data from Wikipedia and if you get some data from research articles, which data are more reliable? So reliable data are quite unique and quite useful compared to the other data. So source is also quite important, and there are too many sources out there. So moving on to velocity. Velocity in the sense like how fast you get the data. How fast I get the previous point I mentioned. There are like some billion amount of users using Facebook in every minute. So how fast these data getting in, especially if you working with the application which use the real-time data analytics. For real-time data analytics, there are tools like Kafka and Siddhi. Siddhi is from a Sri Lankan company, WSO2. I think there's in Jaffna also, there is a branch of WSO2. Is there anybody working in Siddhi project? Siddhi is WSO2 product. Yeah, anyways. So Siddhi, Kafka, and those things are there to work with the real-time data. So when the real-time data and when the velocity is high, it leads to another set of challenges. How to analyze the data in real time in parallel threads and give the output within milliseconds. That's another problem. It's a characteristic of big data, of course, but it leads to a problem as well. Then moving on to the next, the value. So the value of the data is also getting exponentially increased over time. So I quoted this diagram from a particular website called GoToCon. Basically, what here we are trying to highlight is that so here if we, for example, just imagine you are buying a new iPad. You are buying a new iPad. So that's a one single transaction data. You are buying a new iPad or iPhone or something like that. It's a one single transaction data. You purchase this, paid this amount, and this is the timestamp, and this is the receipt. So in short term, it's highly valuable. But when it goes to long term, does it really valuable? As a one single data point, it's not really valuable. When we go to the long term, what values is the aggregation of data. Collection of data is the what brings the value in long term. So value also getting changed over the time. And based on the data also the value can get changed, because let's say you want to have some sort of a payroll, sorry, not payroll, a post system or something like that. In the post system, point of sale system. So there are, let's say you want to get the data from the users, the buying patterns, purchasing patterns. So if you collect unrelated data points, then it's not really helpful, right? So the value, every data doesn't have the value. So you need to give that value. It's like a gel. You need to cut and polish it, and then the give value. And also the value increases over the time when you get data as a collection, when you're aggregating data, not as a single data point. Single data point might be helpful at the beginning for an individual user, for a company, but let's say you purchase an Apple iPod or iPhone. After 6 months, you don't have any use of that data point as a user, right? As an individual data point, you don't have much use of it. But when you collect or aggregatively take collection of data, then it brings much more usefulness. So it can used by Apple to identify the buying patterns, identify the characteristics of users, and do the analytics, right? So what I want to highlight here is that in my perspective, this can be different from person to person. I'm open for objections as well. In my perspective, these are the 5 characteristics of big data. These 5 characteristics itself lead to challenges and opportunities in big data. So that's the first part of my discussion. The second part, I will discuss some of the research came out and how this big data landscape evolved as a story. So it would be quite interesting for you. So before moving on to the next, do you have any questions? Oh, also I would like to know, In which year you are currently studying? Are you in your final year, or are you in your third year, or is there any other first year, second year students as well? Because the next part is little technical. Based on the audience, I can make it narrowed down discussion or broader discussion.
So it's actually a mix. We have first years as well, and second year is
Okay.
also there. All are there.
Okay. All right. So I will make it sort of a broader discussion, but if there are any specific questions, I'm happy to answer. And also, yeah, I on and off I supervise final year research students. If there are any interesting research in big data, I can be external supervisor in addition to your lecturer at the campus. I'm happy to supervise, like, not many. If you are a final year student, I would like to supervise 1 or 2 students. Not more than that, because I'm also quite limited in time. Yeah, so there's a question. I will address that and move into the next stage. So there is a question, can you explain a little bit about big data analytics? Okay, so big data analytics is something like this. So there is a bigger umbrella term called data science. So data science is sort of like a very big umbrella term, which we can fit everything in. We can fit AI in, we can fit data science in, we can fit big data in, we can fit data engineering in. So it's sort of like a bigger umbrella term. So data analytics is something under that bigger umbrella term, specifically used by, okay, so let me put it this way. So, okay, if we take machine learning and deep learning and machine learning both, we use machine learning and deep learning mostly used by researchers. They used heavy Python scripts or R scripts to do the predictions, apply the machine learning models, come up with the predictions, identify the patterns. On the other hand, so that machine learning and AI is heavily relying on algorithms. Algorithms, programming, Python, R, predicting, identifying patterns. Data analytics is the question you asked, right? So in data analytics, it's also pretty much the same, but it's more of a visual aspect. Mostly companies use data analytics nowadays, the data analysts and business analysts. Those two guys are quite, there are some intersection points of those two roles. Business analysts and data analysts, those guys are doing some analytics and do some nice visualizations. So the data analytics are more of SQL focused guys, SQL focused, data visualization focused guys in the industry. In the research, I honestly don't know much about it. In research, I think we don't divide it in such a way. But in industry, data analyst and business analyst guys are who do the visualizations most of the time. They are good at SQL. They are good at statistics, that aspect. On the contrary, the data scientist or machine learning guys are more of like programming based, very deeply involved in algorithmic, not algorithmic programming, but implementing algorithms, doing the prediction, applying uh, uh, statistics there. So that's the difference which I see in data analytics and machine learning. So there's a nice question, another question. I will discuss about that question only, and then rest of the questions, let's keep it to the end. So in Sri Lanka, there's a question from one student. What's the privacy policy and data governance policy in Sri Lanka? Yeah, maybe I'm not the best guy to answer that, but as far as I know, we have in European Union, they have General Data Protection Act, GDPR. Yeah, General Data Protection Regulation or something like that. In Sri Lanka, we have something called, it's developed based on GDPR. In Sri Lanka, we have something called Data Protection Act, just Data Protection Act. It's like 30 pages sort of a document. I downloaded it once, but I have never read it. It was developed by ICTA set of lawyers. Basically, a derived version of GDPR in European Union, which elaboratively discuss all these cybercrime, all these things related to data, how the data can be used. For example, this is something I learned in my master's. I did my master's in big data analytics. So for example, let's say nowadays when we go to the supermarkets, they ask our contact number, right? So they ask our contact number, and if in some supermarkets, even if we don't give the contact number, they ask us to go. That's very ridiculous in my opinion. So in legally, I have read it somewhere. In legally in Sri Lanka, we have the right, as the customers, we have the right to not to give our contact number or get opt out from their databases. But the problem is again in Sri Lankan context, these laws are not functioning really well. They as for paper, these laws are there, but those things are not really functioning well. But to answer your question, there's a Data Protection Act, 40 pages, but it's not really functioning well, in my opinion. I hope I addressed the two questions. So let's move on to the next part, and then if you have any other questions, I will address at the end. So as of we having some first year and second year students as well, I would like to make it little broader, and I will discuss it as a story. If you want me to narrow it down, let me know, then I will narrow it down. Okay. So I would like to start with the beginning, how the big data started. So it's quite funny, like some companies I have seen, they ask for big data engineers experience with over like 10 to 15 years. But the problem is big data was not existing at the time. It came out like very recently, 2003, 2006, uh, predominantly put out there by the company Google, and then it evolved as an open source ecosystem, which I will discuss. But that's very weird. I mean, we can't find data engineers with over 20 years of experience because it's a very recent thing. Some of the concepts might be started in 90s, theoretical concepts, but as a topic, as a domain, it evolved very recently. So the initial big problem, big data as a subject faced was to how to find a needle in a hairstack. Hairstack, right? It's what it called. In Sinhala, we call it piduru. Is it here or here or whatever? So how to find a needle in hairstack, which means when we have like petabytes of data, this is a problem which Google identified at the beginning of the internet. They wanted to like create the Google search engine, optimize it. So they want to identify, like it's like a finding a needle, right? Finding a website in Google, their index, it is finding like a needle. There are like billions of websites. So what they wanted is they had peta and maybe not petabytes of data. They want to find out a single data point. It takes ridiculous amount of time when they use at the time, like when they using their SQL and NoSQL databases at the time, it took ridiculous amount of time. So users which use Google not gonna wait like 10 to 15 minutes after running a search query, right? We need immediate results. That's the problem which everything started back then. Okay. So Google put out 3 research papers. So as our host Compere mentioned at the beginning, big data is heavily relying on research, very backed and foundationized by research. So that's why there is more opportunities for research in big data. So when I'm referring to big data, I'm not necessarily referring to machine learning. Don't get confused. Under the data science umbrella term, there are many domains. Big data is a one. Machine learning is a separate thing. Big data is mainly how to store massive amount of data and how to visualize them. Not necessarily to analyze them. I'm not gonna go deep in that analyzing aspect. Because in these days, everyone is hyped up about AI and everyone trying to use it. I'm sort of like someone who against it. I want people to I want people to know there are other interesting fields as well, not AI all the time. So when I'm referring to big data, I'm not referring to AI. I'm referring to how to store these large amount of data and how to visualize these large amount of data and how to query. When we have peta and zettabytes of data, how to query one single data item, right? In chat box, I think I can see a question. I will answer that at the end. So Google put 3 research papers at the beginning: Google File System, MapReduce, and Distributed Storage System. So they mainly face 2 challenges at the beginning. One is when they have terabytes of data, thousands of disks, thousands of machines, thousands of servers. How to store the data with minimum downtime, minimum data loss. The second thing is how to parallelize computation. So mainly if you look at here, the MapReduce is to parallelize the parallel processing. How to parallel process data and efficiently query. How to handle the data efficiently using querying, using parallel processing. So those are the 2 problems that they had at the beginning. They put out 3 research papers, still available, public. So I have put the source as well. So I will be sharing these slides with you. It will be available on my website, indrajith.net. So you can download the slides and even access these sources and take a look. So these are the 3 papers that they put out. But there was a problem, there was a catch. Because these, even though Google implemented Google File System, MapReduce, and Distributed Storage System called Bigtable, those are proprietary. What does it mean? Those are for their internal use only. They put out some research papers where people can read and understand the architecture, but the code is not open source. Code is proprietarily owned by Google. They don't want to share that. So what happened was there was a guy called Dog Cutting in Yahoo. So he at the time he is working at Yahoo. I'm speaking around back then, like 2003, 4, that time. So he was working at Yahoo, and he was developing a platform called Nudge for Yahoo. It's sort of a like Nudge is a even still it's working, functioning. Apache, I think it's Apache Nudge now. Nudge is more of a crawler, Google crawler to scrape the data from the internet. So he was developing a platform called Nudge. And while developing that platform, he also got faced the same 2 problems that Google faced at the beginning. How to do the parallel processing, how to find the needle in the haystack, how to find the data point in the petabytes of data, how to reduce the downtime, how to do the parallel processing. So he faced those 3 problems when he is developing Nudge. So then what he did was, he created a sub-project under Nudge called Hadoop. And that's what basically in Hadoop, what he did was he read the papers of the Google File System, MapReduce, and Bigtable. He replicated the proprietary software which introduced by Google as an open source platform. So Yahoo, the company that he was working at the time, let him open source the Hadoop. Under the Hadoop, there were 2 components, MapReduce and HDFS. Is there anybody have heard of MapReduce and HDFS? Cool, nice. There are a few questions in your chat. I will answer them at the end. Okay. Otherwise, we are okay. You have heard of MapReduce and HDFS. Nice. So this guy is the one who found it. So the logo came from this toy he is handing, toy in his hand. Actually, there was a nice article which I read back then. This toy is one of the toys from the toy collection of his son. So he put the elephant face to the logo of Hadoop. So basically, Google are the pioneers addressing the problems that they had, but those things are proprietary. So someone need to read these research papers and replicate it and make it open source. So that open source software is Hadoop. Nowadays it's not a software, it's an ecosystem. It was created by Dog Cutting. Now it's open source. It has 2 components, MapReduce and HDFS. So MapReduce allows to do the parallel processing. It has 3 components. Initially, we have the mapper, and then we have a shuffling stage, and then we have the reducer. It's little complicated, so I'm not going to go in deep, but if you are interested, you can read about MapReduce. Nowadays, pretty much nobody used MapReduce, but that's how it started. Okay. HDFS stand for Hadoop Distributed File System. So MapReduce will be running on top of HDFS, Hadoop Distributed File System. Okay. So I hope I covered it. And now that's the end of the time span 2006. At the end of the 2006, Hadoop came out. It looks quite nice. It's like not a bread and butter, but it's quite difficult to set up, but quite useful. So it was at the time it was sparking a lot of interest, like AI nowadays. Everybody is interested in AI, right? So at the time, everybody was interested in Hadoop, which was open source software that Yahoo created. It's called Apache Hadoop because I think it's published under Apache license. So now we are coming into the next stage, 2007 to 2012. I'm again speaking about the research which went through how the adoption happened. Okay, so adoption initially started with the tool Hadoop. Nowadays, it's ecosystem as I mentioned. So once Yahoo put Hadoop as an open source software, everybody started using it. It's like rushing into a bandwagon. It's a English idiom. Everybody's rushing into it like AI nowadays. So everybody's rushing into it. Yahoo is the initial company who created it. Then Yahoo created something called Pig. Now it's under Apache open source license. So they created a Pig to because Hadoop and MapReduce was quite complicated at the beginning. Setting it up, installing, managing clusters themselves with MapReduce jobs is quite complicated. It was not very easy as like walking park. So there were some alternative tools also coming in to make the process easy. And setting up Hadoop itself requires some effort. So Yahoo came up with something called Apache Pig. It's now an Apache license. It's a ETL tool where we can run MapReduce jobs using Pig queries. There are Pig queries, Pig sort of translating language. Then Pig came up. Facebook put out 2 open source projects. One is called Cassandra and the other one is called Hive. Hive is very nice thing because Hive is very similar to SQL. So everybody knows SQL can easily do Hive. So what it does is basically Hive, like rather than users directly interacting with MapReduce, Hive, we can write SQL-like queries in Hive, and Hive will convert it into MapReduce jobs in Hadoop. So you don't really need to work with MapReduce jobs, which is complicated at the time. So you can use the SQL-like queries, SQL-like codes on Hive to run your MapReduce jobs. So Hive is quite useful. Cassandra is sort of a column-based database. It's a wide column NoSQL database. It's not necessarily part of the Hadoop ecosystem, but it also quite widely adopted because, I mean, it doesn't require function. It doesn't require Hadoop to function, but it widely adopted in the ecosystem, in Hadoop ecosystem. When we are working with MapReduce, Cassandra is always coming up. And then a company called, I think it's called, I can't recall the name. A company, a not well-known company came up with HBase. So HBase is again a column-based database, which they wanted to create a Google-like search engine. Later, HBase was acquired by Microsoft, and Microsoft now use HBase for their Bing search engine. So all these things coming up during this time to the bandwagon. All these tools are running on top of Hadoop, specifically MapReduce. Hadoop has 2 layers, HDFS and MapReduce. These tools are running on MapReduce. These tools are integrated with MapReduce and easy to work. And then even AWS jump into the bandwagon. AWS, Amazon Web Services, they introduce something called Elastic MapReduce, where you can run MapReduce job on cloud. So adoption was like quite rapid. Okay. Everybody's jumping into it. New tools are getting popped up every day, like AI in these days. In these days also AI tools are coming up like mushrooms. Everywhere we can see AI tools. At the time, it was quite the same. But there are a few problems in Hive. So out of these tools, Hive was the most adopted one, which made open source by Facebook. Hive is used to create MapReduce jobs using SQL-like language. So you don't need to know mapper and reducer, how to create the mapper and reducer, write the Python scripts. I think Scala was also you can use to write map and reduce, but Hive is quite easier. So Hive was quite widely adopted at the time, but Hive had some problems. So what are those problems? Hive is like an elephant. So if you ask an elephant to do a job of mouse or mice, elephant can't do it, right? Elephant has very big legs and big feet and all. He can't do the small tasks. So what happened was that when we using Hive in large data warehouses, it's good to handle the large databases, but when we have a standard SQL databases using Hive, and when we want to uh, scan the table, scan few rows, it takes some time, few milliseconds. Few milliseconds is quite a ridiculous deal because humans don't really like the lag. Even the milliseconds hurts. So Hive was not that fast because Hive is something running on top of MapReduce. It need to be converted into MapReduce and then run. So again, Google came in. Google introduced something called Dremel or Dremel. So it's also a research paper available on the internet. Sources available in the slides. You can see here. So Dremel is called interactive analysis for web search datasets. So it had like couple of innovations within. Like unlike in Hive, it was able to like do the uh, quick searches in SQL column-oriented storages. And it was later inspired into new data storage formats. So it was quite a big deal at the time. Then inspired by Dremel is also, if I'm not mistaken, it's also proprietary. Inspired by Dremel, open source player create something called Tess. So inspired by Dremel, some guy in the open source, I can't exactly recall the company name. I think it's Dream something. I can't recall the company name. So it's like a nice history story, but you also can read it because some names I don't exactly remember. So Test was created, inspired by Ramel, to make the Hive faster. It also an open source project. Most of the people in big data, they consider Test as the version 2 of MapReduce. So Hadoop had two components, MapReduce and HDFS. In the around 2012, people considered Test as the version 2 of MapReduce because Test make Hive faster. Right? So the open source project Test didn't change the Hive itself, it changed the MapReduce. Then it led to run the Hive queries faster, but it inspired by Dremel project by Google. Right? So it's a nice story, mainly backed by research. I will later tell you like what sort of research projects you can do at the end. So don't lose your interest. So we are coming into the era 2012, 2016. Like humans are always evolving and get the things do easier, right? We find out a way to do the things that we did all the days easier. So Spark came into the picture. Apache Spark is also a separate open source project. It got some traction, like in the beginning of 2012. It was a like best replacement for MapReduce. Not Hadoop ecosystem, but it's a replacement for MapReduce. So it has a better syntax. It supports multiple programming languages, including Java, Python, Scala. It even supports Hive. You can write Hive queries with Spark. It supports Spark. There's a language called Spark SQL, Spark SQL. You can write SQL queries in Spark. Better capabilities, simple syntax. And it was very faster than MapReduce, of course. So it was like a wildfire. Everybody starting to use Spark out of nowhere. It's like ChatGPT. not necessarily like that. It came out like little and little because at the beginning Spark was not so stable, but later they were managed to make it stable software. But so nowadays it's MapReduce is completely or 95% replaced by Spark. You may learn MapReduce in your universities, but it's replaced by Spark. So Spark is also a way where you can do this parallel processing. And you can easily find out a needle in the hair stack. That's the initial problem that we have started, if you remember. So, so in the same time, during the same time, separate to Spark, the real-time data also coming up, like real-time data activities are also getting increased. So LinkedIn came up with Kafka to manage real-time data. Then Apache came up with a project called Storm. Kafka is also open source today. So those things also came up separately to the Spark. If we try to speak of the proprietary side, Google, AWS, and Azure came up with some innovations. I'm gonna come into these things again. They came up with BigQuery. Google came up with BigQuery, and AWS came up with Redshift and Snowflake. So these tools were used to create the large data warehouses and do the SQL-like analytics in those data warehouses with minimal programming knowledge. So in the proprietary sites, those tools also getting emerging. Spark also getting emerging during the time. Also the tools like Kafka for the real-time data analytics also getting emerging. That's the origin of Spark. Then most recent time, Hadoop actually died. I mean, there are players who still use Hadoop, but it's almost dead. Mostly, I identify like few things which replaced Hadoop. There were like a massive trend of cloud, public cloud. You can see in the slides. Mostly, the data nowadays, data is going into the public cloud. That's why it's important. All the data is merging into public cloud in a very rapid phase. So massive migrations were going from private cloud to public cloud. It led to not to use HDFS. HDFS is mostly used in private clouds within the organizations. So it led to storage like S3, Amazon S3. Everybody is using Amazon S3, Google Store, Azure Blob Storage, etc., etc. Rather than relying on HDFS. If you remember, Hadoop had two components at the beginning, HDFS and MapReduce. HDFS was replaced by the cloud providers, cloud storage. MapReduce was replaced by Spark, right? So also there's another Hadoop killer, like critical Hadoop killer. That Hadoop killer was like deep learning, because Hadoop, if you remember the initial problem that we started with, all this big data ecosystem is created to finding hair stack, so needle in a hair stack. Query the data, like writing optimized queries. That's how this ecosystem evolved. But this ecosystem is not optimized for machine learning. When the deep learning came into the picture very recently, it's a like killer for Hadoop, because Hadoop is not optimized for deep learning. It doesn't work with deep learning properly. That's why that's a major shot. Like HDFS and MapReduce replacements are like like it's, if you think of a movie like uh, like hitting into the body, like it's hitting into the body, now body getting weaker, and the headshot is the Hadoop, the machine learning evolve, like just to knock off. It was able to knock off Hadoop because it was not optimized for machine learning. So so data scientists primarily need two things: good GPUs. They need GPUs, which is very hard to work with Hadoop. So I'm not going to explain it, why it's hard to implement GPUs into Hadoop cluster. Also, they need to use the latest libraries like TensorFlow, Keras, Pandas, NumPy, and all the other libraries. So which is quite hard to do with Hadoop at the beginning. Now it's possible. At the beginning, Hadoop was not evolved to use those libraries. So with the development of machine learning, with the replacement of HDFS, with the replacement of MapReduce, Hadoop is pretty much died. There are companies still use it. I somewhere read Uber is still using Hadoop. Maybe if there are companies who are relying on private cloud, like the cloud within the organization, they probably using Hadoop. But other than that, it's mostly dead, right? So it's quite interesting, right? You might now also quite interested about the story, how these things getting evolved. So you at the end you will get the sense what things you should focus now, right now. What should be the trend in the future? So when you are doing your research, you can focus on to that. Okay. So now we are moving into the last part, the modern era. The modern era is not data warehouse. There's a new thing called data lake, which I haven't explained earlier. So data warehouses and data lake both are when you work with big data, we can't store them in bases. We can't use the relational modeling to store the data. So we have data warehouses for SQL-like data. When we have SQL-like big data, we have data warehouses. We have no SQL-like big data, we have data lakes. That's an easy way to put it out, but there are more broader definitions. If you're happy, I will go into that. But data lakes are specifically for NoSQL like data warehouses are specifically for SQL like big data. So in the modern days, now we have something called data lakehouse. It's not the lakehouse building that we have in Colombo, but it's called data lakehouse. So it's the combination of data warehouses and data lakes. So that's the modern data approach. So if you like how to put it out. So it's a sort of a platform which combines the both advantages of data warehouses, data lakes. So data scientists and BI engineers, business intelligence engineers, they can use same within the same platform, like data warehouses, NoSQL and SQL data, both within same platform. Apply the governance, apply the security, apply the knowledge sharing in a one single platform rather than doing it in two places. One of the famous data lake houses, initial players is Databricks. So Databricks is, I think, it's introduced by Spark, right? It's a Spark project, if I'm not mistaken. So Databricks is a data lake house, and then later there are new lake houses came in. Snowflake, Snowspark, Azure Synapse, then Google Big Lake. So those are the lake houses. Those will be the trend for tomorrow. So you need to focus on those things. Also, Hadoop, as I mentioned, Hadoop pretty much replaced with Spark, but Spark is not going to die soon. Spark is quite adaptable. Spark is even the Spark project, they created Databricks. Databricks is a data lake house. So they are quite adapting over the time. So you need to know Spark quite well if you want to move into the big data domain. So, again, I would say like many companies are focusing on like even they don't go for Spark, they go for like no code, low code sort of approaches. Like without using very less or no code, there are tools to do it. Like there are projects to do it. We can use the Azure or AWS services where we can use the no code, low code architecture and do the stuff. We don't need to know much about coding or SQL or anything else. We can implement the data warehouses and data lake houses. So that's also an emerging trend. No code, low code in big data. And also lake houses. So that's where we are currently standing out. So at the end, we are moving into a cloud era. So if you do your research, I would like to specify two things. You in a final year project, in a research project, you can't invent something like Databricks. It is involved after a long time. Databricks is a data lake house by Spark. Snowflake is from Azure, right? BigQuery is from Google. Then Azure Synapse is also a data lake house. Snowflake is from AWS. So those are the future data platforms. So you need to know these things, and those things will be the future. And also long term, I believe the long-term winners are the cloud providers, Google, Amazon, and Microsoft. And the other cloud providers like Alibaba Cloud, I don't know anybody using it, but yeah, those things are also there. But the future is cloud in my view, because I am someone working in big data and cloud both. Big data mostly in research point of view, cloud mostly in industry point of view, but I see that's the future is going. So if you want to do your research, I don't tell you to invent something. Identify a burning research gap in one particular tool. For example, now here, so in here I mentioned all the tools in Hadoop ecosystem. There are more than 150 tools in Hadoop ecosystem. So if I go to this link, I think you can see the screen. There are more than 150 tools in Hadoop ecosystem. Still to the date, most of them are using. Most of them are actively usable. So what I would like you to do is, some of these tools have research papers. Read the research papers, identify the gaps, go through the online forums, identify the gaps that the developers say, bridge the gap. Don't try to invent a new tool. Just for example, when here I was explaining Spark, sorry, here Dremel, the test was invented to make the Hive queries easier, right? Nobody have reinvented Hive. There was a open source organization which invented tests to make the Hive faster. So don't try to reinvent anything, but try to make something faster, make something more efficient. Identify a pain point in one given tool, because the cloud big data ecosystem is very vast. I'm speaking of big data storage and analytics and visualization, not any AI. So what I want you to understand is, you don't need to use AI in all of your projects, because I don't see any point, because there are not much of job opportunities out there if you look at AI job market. You need to know these things are also out there and quite exciting, as far as even more than AI, right? How this data getting stored? Just think how this data getting stored in your computer. Yes, of course, zeros and ones, but how it getting stored? How the column-based databases are different from the SQL-like databases. So those things, take a look, identify the gaps, try to build a small tool to bridge one particular gap. So if you are reading research papers, I would like to recommend you these two talks. So this is a talk on YouTube by Professor Shana Murthy on IIT Bombay. And this is a medical doctor, but the talk I find quite interesting. So how to read research papers and identify the gaps. Once you identify the gaps, you can build a small tool to bridge the gap. Don't try to invent any big tools, Databricks or Snowflake. You can't do it. It's not possible, because these things are done by very big companies. They have like thousands of developers. You can't do it in your projects. But you can build a small tool to bridge some certain gap. I want to extend the slides with a few of projects which I have recently involved with, and few of the cutting edge big data projects. But unfortunately, I'm a little sick today and I didn't have much time to complete the slides. So I would like to, as the 1 hour time is also done up to now, I would try to stop here. Maybe we can do another session later on if you are very interested in this domain. So yeah, I would like to stop it here. And also, all the slides and the materials will be available on our website, indrajith.net. It will be available somewhere in here. And you can also follow me on LinkedIn to be updated. If you need any help for your research, just drop me a message. I would happy to supervise like 1 or 2 students, extremely dedicated students. Because my time is limited. So when I want to put my time into one project, I want you to be extremely dedicated. So yeah, the ecosystem is quite interesting, right? So that's about the big data ecosystem. I hope you got a broad idea. If you have any specific questions, I'm very happy to discuss. There are a couple of questions in chat, so I will address them first. So there are questions again. Data science was AI in future. Yeah. So data science is not related to the topic that we are discussing today, but just to address the question is about what are the opportunities in AI and data science, and what I think about it? I think it's oversaturated, right? Everybody's learning AI and data science these days. So, okay, it's good to know as a utility, but I don't see much of a demand in the industry for that many of AI projects. But I mean, if you like it, go ahead with it. But no offense. But there are many other exciting areas as well.
Excuse me, sir. There are some questions from the
Another
audience.
question. Is it in the chat?
No, sir. Like, why does big data become a major topic with current AI hype?
So you're asking something. Please. Just repeat. I got distracted. That's why.
Sorry, sir. It was
Uh,
there were some questions when we were asking for pre-registration. She asked one of them from that.
okay, okay, okay. Ah, okay. Again, I, I, that's why I couldn't get the entire question.
It's a
Works
little
in
bit
AI. What the
breaking. You can, sir. Hi all, please stay for a few minutes. The speaker will join
I think
soon.
it's fine. Yeah. Uh, I maybe will turn off my video. Can you hear me?
Yeah, sir, we could hear you, but it's a little bit breaking.
I, I can't hear anything. Make sure.
Sir, can you hear me?
Yeah. Uh,
So I think
speaker side, there is a network issue, I guess. So could you please check your connection again? Yeah.
Does it work now?
Yes, sir. You are clear now.
Okay, can you stop sharing the screen? Then I think it would be take
Ah,
less bandwidth.
okay, sir.
Okay. Yeah, let's go to the question. Sorry, yeah. That's what I hate online meetings. In Sri Lankan context, I really hate these internet providers. Anyways, yeah.
So, why does big data become a major topic with current AI hype?
Yeah. So yeah, now I get the question. So here's the thing. AI is quite a promising, right? If we look at the recent tools, like there are bubbles as well, like on and off. We have recently seen the crypto bubble. It was came like 2021 and it was burst. But AI seems quite promising and not looks like a bubble, at least to me. There are quite a vague use cases. So AI is promising in the next 10 years, there will be like quite demanding demand will be created for AI engineers, but I don't uh, so AI will be anyway demandable. I will tell you later why I don't see much of like everybody is jumping into the backend wagon. So that's why I say there will be less opportunities, but AI will be the future for sure. So everybody need to know AI. That's for sure. So when the AI is evolving, AI fundamentally built on top of large amount of data. So all the machine learning algorithms, even the neural networks, deep learning, everything built on top of large amount of data. So when we have large amount of data, we don't have, we need to go ahead with big data storage, big data analytics. Because basically, so far what we have discussed, we discussed broadly about big data storage. So without storing the data, how to do the analytics? So we need to use data warehouses, data lake houses to store the data. And also we need to query the data. Like even before creating AI models, we need to query the data and find out certain things to find out patterns. We need to query the data. To query the data, we need big data querying techniques. To visualize the data, we need big data visualization techniques. So those are the things that also coming up with the increasing demand of AI because AI is predominantly built on top of large amount of data. Without data, AI will be not there today. So that's why those two domains are like correlated. But I personally believe AI is like quite overhyped. Definitely there will be a future, but it's little overhyped in my opinion. But to answer the question, that's why the two domains are correlated heavily. I hope I addressed it.
That's another question, sir. How to use distributed and parallel computing in big data analytics?
So yeah.
Yeah, I think Kavitra is not clear. So Varsha, could you please read the question again?
Yes,
Thanks.
sure, ma'am. How to use distributed and parallel computing in big data analytics?
Yeah, mainly when we are referring to distributed computing, we are mostly referring to parallel processing. So why we need parallel processing is essentially because when we have like large amount of data, so the basics of parallel processing is sharding and partitioning. I hope you have heard of at least most of the university curriculums. It's there. So sharding and partitioning is one way. There are many ways where we can parallelly process something. So it gives quicker results. That's why the distributed computing and parallel processing comes up. So I hope the question is why it's a big part of big data. Is that the question? Why it's a big part of big data, or is it something else?
It's like how we could use distributed and parallel computing in big data analytics.
Okay. So in big data analytics, today's world, so we discussed pretty much of a number of tools for parallel processing. So I would say you don't need to really configure the parallel processing. It's like writing something in ASCII language or something like that. So we don't really need to go into that deeper level with the today's technologies. Initially, MapReduce came up for parallel processing. So in the MapReduce, what happens is that there are three components: mapper, shuffler, and reducer. We parallelly process, for example, for a simple if there are millions of records, and if you want to find out one, it parallelly will process and get to the output. So honestly, from my end, I don't really know how the parallel process algorithm works. Basically, I write the mapper and reducer to do the job. It's a Python script, and it will do the job simpler. So moving into the today's world, we don't use MapReduce anymore. We have Spark. Spark is way easier than MapReduce. In MapReduce, we need to write two files, mapper and reducer. We need to configure it into the cluster, so it's bit of a work. But with Spark, we can easily do parallel process. We don't even know parallel processing happening in the background. So automatically parallel process will happen in the background. To be honest, I don't know the answer, because when we are using tools like Spark, it doesn't let the user know the parallel processing is going on. It's like using a computer in today's world, right? So when you are using your computer today, you don't really know what's going on now. Like let's say when you are opening up the Zoom meeting, you don't know whether it's the parallel processing is using, or how many threads are there, multiple threads or single thread. Same thing to big data. We don't know how many threads are there, how the parallel processing works underground. Basically, Spark is there to abstract that layer. So it's lots of simpler. Even the developers don't even need to think about that. But if you want to go in deeper, of course, in research, you can read few research papers. I'm not too sure about that answer, because when we are using Spark, mostly, we don't even realize parallel processing is going in background. It's going in background by default. I hope I addressed it.
Yeah, okay, sir. And there is another question as well. How much affordable is accommodating a big data solution, especially return of interest in the context of Sri Lanka?
Okay, that's quite a broad that's quite a broad question. In Sri Lankan context, big data solutions. So in Sri Lanka, there are already big data solutions. You know what? Like the massive retail companies like John Gears and Cargills and those guys, they have data warehouses implemented. I'm not too sure whether it's on-prem or cloud, but they have their own data warehouses implemented and they do the analytics. So in Sri Lankan context, we can't say it's not there. It's there, but like it's quite costly, of course. We need to agree that. So we need to compromise uh, cost a little. So it brings the value. It works like this. So a company like Keels use the previous 10 years of data to analyze the customers' buying patterns. Once they analyze the customers' buying patterns, they can upsell and market their products to that particular customers. For example, let's say there's a famous story you also might have heard of: beer and diapers. That's something happened in UK. In UK, there's a large retail store called Tesco. It's like Walmart or Food Cities in Sri Lanka. So what Tesco guys found out was beer and diapers goes together. When someone buy beer, they also buy diapers. The reason is quite weird reason. You can read about it later, but Once they identify the buying patterns, they can push or upsell their products and increase their business. So they need to compromise a little because developing a big data solution will take time, money, and effort, infrastructure, of course. They need to compromise that little bit of money, the little bit of resources, but in long run, it would be helpful for them. If you remember the graph which I shown to you, when the data getting aggregated over a large period of time, the value getting increased exponentially, they can effectively do the marketing campaigns and they will get more business. So in Sri Lankan context, there are companies who are doing it. I honestly don't know whether they use the private cloud or public cloud. But if they go for public cloud solution, it's quite expensive. But if someone want to go for a private cloud solution, because if you have an on-premise server, you can implement HDFS, Hadoop. It's open source, it's free. It takes a little bit of effort. Configuration is quite hard, tricky. But you can install Hadoop. You just don't need much. You just don't need to spend much. You can configure Hadoop. You can even configure Spark to run in your private cloud. So you only need the computation, a GPU, computation power, a personal dedicated server, the required knowledge to operate Spark cluster. That's it. So it's doable. It's not that costly, but the less costly options comes with the price. Less costly options comes with the it's more complicated. If you can go for a high cost version, it's less complicated. Like if you go for like Google BigQuery, if you go for Snowflake, or if you go for data lakes available out there, it's expensive. On the other hand, it's simple to use. So the company can decide what approach they can go for. But in Sri Lankan context, there are companies who are already doing it.
Thanks, sir. And I have received another question in the direct message.
Okay.
What things we can do with big data in health sector? What things we can predict?
Okay. All right. So if you are interested in such a research, so in Sri Lankan context, of course, I don't think this is done by anyone else, but I'm not someone directly working in the health sector, but I think there should be some projects which collect all the patient data, drop it into a data warehouse or data lake, and then use those data for future analytics, right? Analytics in the sense the predictions. Like for example, if there is a patient with, let's say, I don't know, I'm not a health professional, but if there is a patient with cough, continuous cough for like 2-3 times, if that patient have taken medicine for cough 2-3 times in a year, then there might be something correlated to that cough, right? Continuous cough might be correlated into cancer or something like that. So the machine learning model will come up with that. Like machine learning also quite heavily coupled with big data. So in today's session, I'm mostly discussing about big data storage, analytics, and visualization, not necessarily machine learning part. But mostly when we go into use case, always the prediction component also comes in. Use case is more of vague solution. We might have a big data implementation, big data analytics implementation, machine learning part, then data science part, visualization part. So when we go into real world projects, it requires all the other components in the data science umbrella as well. Speaking of the latest tools for your case, I don't really recommend going for MapReduce because it's old and nobody uses it anymore. I recommend going for Spark. In Spark, they have a data lakehouse called Databricks. So Databricks is free to use for students. So I think there are some limitations, but it's free to use because I use Databricks to teach my students when I teach at IIT. So if you can learn something like Databricks, it would give you a good foundation. So in your projects, if what you could do is, if you have access to a large sort of a data set, you can build an architecture, efficient architecture compared to the architectures available out there, efficient and proven architecture you can do some certain analytics using big data architecture. Like let's say data goes into the data warehouse first. Through the data warehouse, there are two data streams, historical data stream and the real-time data stream. Both go into data warehouse. Real-time data stream will analyzed by real-time using something like Kafka. Historical data will be analyzed using Spark. Then the two analytics reports will be combined. And you can think of a diagram like that. Two analytics report will be combined and come up with final report. So if you can consider that as an architecture, that's a good research. For certain project, you can come up with a big data backed architecture, how the data going to store, how the analysis will happen, how the things are interconnected, how these things are communicated. And if you can implement the same using open source tools and benchmark it, if it is efficient than the existing tools available out there in the industry, then it's a good research. You can even publish it in a good conference. I hope I gave the broad answer about the tools and about the healthcare sector.
Yeah, thanks, sir. Now I'll hand it over to Kavitra to continue.
All right, okay.
Thank you. Good evening, dear sir, Mr. Indrajith Ekanayake. On behalf of the IEEE Women in Engineering Student Branch Affinity Group of the University of Jaffna, I would like to extend our heartfelt gratitude for your invaluable contribution as the speaker on opportunities and challenges in big data, Volume 1 of our Igniting Research Passion series of sessions. Your expertise provided a profound understanding of the subject matter, enriching the experience for all attendees, and your passion for research and dedication to sharing knowledge are truly commendable and have inspired us all. In appreciation of your outstanding presentation and contribution of your time and effort, we would like to express our gratitude by presenting you with a virtual token of appreciation. Dear sir, please accept it kindly, and we will look forward for many opportunities to collaborate with you in the future. And dear attendees, your active engagement and thoughtful contributions made the event a truly enriching experience for all, and your eagerness to learn and willingness to explore new horizons exemplify the spirit of curiosity and passion for research that we aim to foster within our community. And thank you for your participation and for being an integral part of our journey towards igniting research passion and fostering innovation. And also we invite you to join us for our upcoming sessions in the Igniting Research Passion series. These sessions will cover a wide range of topics aimed at deepening our understanding of research and innovation. And stay tuned for more details and registration links for each session. And once again, thank you all. And we request all of you to turn on your cameras if you are at a position to turn it on. And we understand that some of you may not be able to turn on it, but it will be great if you can turn on your cameras for a while.
We'll wait for a few more seconds. If that's all, we can capture the moment. Okay, I guess that's it. Okay, someone's turning on. Let's wait for a few more seconds then.
By the way, in Jaffna, it might be hotter, isn't it?
Yeah. Okay. We'll go in a count of 3. 3, 2, 1, say cheese. Okay. Thanks all. Thank you, sir. Thanks again for accepting our invitation. Hope to have another session with you again. Thanks all for joining as well. We hope to see you all in upcoming sessions too. Thanks.
Yeah. Thanks for inviting. Yeah, let me know if you need any inputs from my end. If anyone interested in doing research seriously, let me know. Drop me a message on LinkedIn. We can see. All right. Thanks. Then good night. See you.
Yeah, sure, sir. Thanks. Good night.